This is question 6. The suction and discharge pipe of a pump are connected to a differential mercury manometer. The diameter of the suction pipe is 200 millimeter and the diameter of the discharge pipe is 150 millimeter. The specific gravity of the pump liquid is 0.81. The manometer reading is 600 millimeters. Determine the pressure head across the pump. If the discharge is 115 liter per second, the center line of the suction and discharge pipe are at the same level. So in this question, I hope you could draw diagram from the question. So after you read this question, I hope you could draw a diagram like this. Okay. So the basic idea is we have a pump here. So however, the cross-sectional area for inlet and outlet pipe here is different. So we have a bigger cross-sectional area at inlet. However, we still believe that pump is a device which add energy to the flow. So we found that the energy at point number 2 is higher here. At the same time, it will create high pressure. So because it is high pressure at point number 2 here, so it could press the manometer fluid here deeper compared to the left hand side. So I hope you could draw a diagram like this one. So and then this is the Bernoulli equation. So and then we know that we need to add head of pump in the inlet. So and then we assume that the level of Z1 and Z2 here is equal. So we could assume that Z1 and Z2 is equal to 0. So and then from the question, it given the value of flow rate 115 liter per second. So we convert it into 0.115 meter cube per second. So with that flow rate, we could calculate the value of V1 and V2 as mentioned here. So and then to calculate the HP here, we need to bring all these parameters to the right hand side, and then we could calculate the value of HP. And then from the flow rate, we already know the value of velocity. So means that the value of this one and this one is already calculated. But we need to calculate what is the value of P1 and P2. So we could calculate the value of pressure because the difference of manometer gauge here is given. So the difference is 600 millimeters. So here you need to use your idea, your knowledge from the fluid mechanics one. So what we need to do is, so we assume that we have point here as point number 3 and we have another point here as point number 4. So because this level is, it stays at same level, so we could say that pressure at point number 3 is equal to pressure at point number 4. So we could write an equation like this. P3 is equal to P4. So according to this location. So and then we could calculate the value of P3 by looking material on it. Okay, so let's say we assume that this height is equal to X. So and then we could calculate the pressure that occur at point number 3 is actually the rho GH of this one plus rho GH of this height and plus the pressure that already exists at point number 1. So if we write the equation, so we have equation of this one. So we have the rho GH from the mercury. So we have rho GH from the liquid in the pump and the pressure that already exists in point number 1. So and then for point number 4 here, so we have rho GH of this liquid plus the pressure that already occur at point number 2 here. So and then we could write the equation of this one, rho GH 0.6 plus X plus P2. So and then because P3 is equal to P4, so we could substitute the value of P3 here and P4 substituted here. So and then if we do the simultaneous solution, we could get P2 minus P1 is 75,281.94 Pascal. So and then we rearrange the Bernoulli equation from here because we aim to calculate the value of head of pump. So we bring all these parameter to right hand side. So we have this term and then we could calculate the value. The value of V2 and V1 is already calculated here. So and then the value P2 minus P1 is equal of this value. So if we substitute here, we could get the head of pump is 10.95136 meters. So bear in mind in this calculation, because we are using specific gravity of 0.81, so means that the density of that liquid is 810 kilogram per meter cube. Okay, so I hope you could do this at home, and please make a revision on how to measure pressure from the YouTube manometer. So we learned this in fluid mechanics 1.